sun goes down. When you're gone, I lose faith, I lose everything I have found. Heartstrings, violence, that's what I hear when you're by my side. Yeah, that's what I hear when you're by my side. But when you're gone, the music goes, whoa, 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 whoa. I lose my rhythm, lose my soul, whoa, 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 whoa. So hear me out before you see the night is over. I want you to know that we gotta carry on. So don't let this be our final song.
Cak, I want to change the color of my car. Do you have any recommendation shop?
Of course I know, so why don't we go and take a look?
Let's go. Let's go.
Welcome, have a seat.
Okay, thank you.
The provided code defines a C++ function named error message that displays an error message indicating invalid input. Please try again on the console. The function then prompts the user to press a key to continue using system pause and clear the console screen with system CLS. This code is likely intended for a console-based application where the user is expected to enter input and the error message is displayed in case of invalid input, prompting the user to try again. The use of system pause is a common way to wait for user acknowledgement before proceeding, and system CLS is used to clear the console screen for the cleaner display.
The provided code defines two functions, paint color and select type, which prompt the user to choose a paint color and finish type, respectively. In the paint color function, a loop displays a menu of color options. Take user input for a color code, validates it, and increments a corresponding color count. The chosen color is then returned. The select type function follows a similar structure for finish type. Both functions utilize a system-specific command to clear the console screen. In case of invalid input, an error message is displayed through the error message function, ensuring the user makes a valid selection before proceeding. The overall design facilitates user interaction in selecting paint options for a project.
These two functions facilitate the selection of red color and quality type for vehicle customization. The red color function prompts users to choose a red color from a predefined array. It displays color options in a formatted manner and continuously loops until a valid color code is entered. Upon receiving valid input, it updates the count of the selected color and returns the corresponding color. In case of invalid input, it calls the error message function to handle the error and guides the user to input a valid option, ensuring a smooth selection process. Similarly, the red type function guides users in selecting a quality type for vehicle wraps. It presents quality options to users and continuously loops until a valid quality type code is entered. Once a valid code is received, it returns the corresponding quality type. If the input is invalid, it calls the error message function to handle the error, maintaining the integrity of user input. This function collectively enhances user experience by facilitating seamless color and quality type selection for vehicle wraps.
The provided code defines a function named dashboard cover that facilitates the selection of a car dashboard cover based on the car type specified as an input parameter. The function employs a loop to continuously prompt the user for their choice among three dashboard cover options, each associated with a specific price stored in a two-day array. The display menu includes details and price for anti-slip car dashboard cover, Navy carbon fiber dashboard cover, and polyester dash cover mat. User input is validated, and upon a valid selection, the corresponding dashboard cover price is returned. In case of invalid input, an error message is shown through the error message function. prompting the user to make a valid choice before proceeding. Overall, the code provides a user-friendly interface for selecting a dashboard cover for a specific car type. The provided code defines a function named armrest designed to facilitate the selection of a car armrest based on the specified car type. The function utilizes a loop to repeatedly prompt the user for their choice among 3 armrest options, each associated with specific price stored in a 2D array. The menu displays details and price for anti-scratch leather armrest, microfiber leather armrest box cover, and a carbon fiber armrest cover. The user's input is validated, and upon a valid selection, the corresponding armrest price is written. In the case of an invalid input, an error message is displayed through the error message function, prompting the user to make a valid choice before proceeding. Overall, the code provides our user-friendly interface for selecting an armrest option for a specific car type.
This coding defines a function for selecting seat covers for a car. It declares variables including seat cover to store the user's choice, any key possibly for user interaction, and more to control the loop. It initializes a 2D array seat cover price to store the prices of different types of seat covers for different car types. It utilizes a while loop controlled by the more variable to allow the user to select a seat cover until they choose to exit. It displays a menu for seat covers based on the car type provided, showing options and their corresponding prices. After displaying the menu, it waits for the user to input their choice using CIN and then clears the screen using system CLS to maintain a clean interface. If the user selects a valid option, 1, 2, or 3, it returns the corresponding price from the seat cover price array based on the car type. If the user inputs an invalid choice, it calls the error message function to notify the user and sets more to true, allowing the loop to continue and prompt the user again for a valid choice. This part of the code creates a function to let users pick car maps. It has variables like car maps to remember the user's choice, any key for user interaction, and more to control the loop. There's a 2D array called car maps price, storing prices for various car map types and car models. The code uses a loop controlled by more to keep asking users for car map choice until they want to stop. It shows users a menu of car map options based on their car type and their respective prices. After showing the menu, it waits for the user to enter their choice using CIN, then clears the screen to keep things neat. If users pick a valid option, 1, 2, or 3, it returns the corresponding price from car map price based on their car type. If users make a mistake, it notifies them using the error message function and keeps the loop going until they provide a valid choice.
The provided C++ code defines a function called spotRims that take an integer parameter car type. This function presents a menu of spotRims for a specified car type and allows the user to choose one. The menu includes options for different 18-inch car spot rim, displaying their corresponding price. The user is prompted to input a choice, and if the input is valid between 1 and 3, the function returns the selected spot rim price. If the input is invalid, an error message is displayed using the error message function, and the user is prompted to try again. The function continues to loop until a valid choice is made, ensuring a proper selection of spot rims. Additionally, the console screen is clear after each customer interaction for a cleaner display. The provided C++ code defines a function named bumper cover that takes an integer parameter car type. This function facilitates the selection of bumper cover option for a specified car types, presenting a menu with choice for bumper cover equipped with various features. The menu displays price for bumper cover with park sensors, headlamp washer, and reverse sensor. The user is prompted to input a choice, and if the input is valid between 1 and 3, the function returns the corresponding bumper cover price. In the case of an invalid input, an error message is displayed using the error message function, and the user prompted to try again. The function employs a loop to ensure the user make a valid selection, and the console screen is clear after each interaction for improved readability. The given C++ code defines a function called hoodCarbon that takes an integer parameter car type. This function enables the user to select option for a carbon fiber hoods for a specified car type. The menu presents choice for tuning carbon fiber hood bonnets and carbon fiber tempered glass hood bonnet. Displaying their respective price, the user is prompted to input a choice, and if the input is valid between 1 and 2, the function return the corresponding hood price. In case of invalid input, an error message is displayed using the error message function, prompting the user to try again. The function utilizes a loop to ensure the valid selection, and the console screen is clear after each interaction for a clear display. The provided C++ code defines a function called spotSpring that takes an integer parameter type. This function facilitates the selection of spot spring for a specified car type, presenting a menu with options for different color lower spot springs. The menu displays price for black, red, pink, gold, and blue lower spot springs. The user is prompted to input a choice, and if the input is valid between 1 and 5, the function returns the corresponding spot springs price. In the case of invalid input, an error message is displayed using the error message function, prompting the user to try again. The function utilizes the loop to ensure a valid selection, and the console screen is clear after each interaction for improved visibility. The provided C++ code defines a function called spoiler that takes an integer parameter car type. This function allows users to choose from a menu of spoiler options for a specified car type. The menu includes selection for a tuning carbon fiber, ductile rear spoiler, and a carbon fiber matte wing, each displaying their respective price. Users are prompted to input their choice, and if the input is valid between 1 and 2, the function returns a corresponding spoiler price. In the case of invalid input, an error message is displayed using the error message function, prompting the user to try again. The function utilizes a loop to ensure a valid selection, and the console screen is clear after each interaction for a better visibility.
This coding likely represents a function responsible for handling accessory options for a car based on the car type provided as input. The variables declared include more, a boolean to control the loop, add presumably for additional accessories, choice to store the user's menu choice, interior, exterior, possibly for sub-options, and accessories total, exterior price, interior price, and total price for tracking costs. It utilizes a while loop controlled by the more variable to allow the user to select multiple accessories until they choose to exit. It displays a menu for interior and exterior car accessories, prompting the user to make a choice. After displaying the menu, it waits for the user to input their choice using cin, and then clears the screen using system CLS to maintain a clean interface. This section of the code is responsible for handling the user's choice of interior car accessories. It begins with an if-else ladder to determine the user's choice of interior accessory based on the value stored in the variable interior. It displays a menu for interior accessories such as dashboard cover, armrest, seat cover, and car mats, prompting the user to make a selection. After displaying the menu, it waits for the user to input their choice using cin, and then clears the screen using system CLS to maintain a clean interface. Depending on the user's choice, it calls specific functions, examples such as dashboard cover and armrest, to calculate the price of the selected accessory and update the interior price accordingly. If the user input an invalid choice, it calls the error message function, notifies the user and sets more to true, allowing the loop to continue and prompt the user again for a valid choice. This section of the code handles the user's choice of exterior car accessories. It follows the previous if-else ladder and checks if the user's choice is true, indicating exterior accessories. Similar to the interior accessories, it displays a menu for exterior accessories like sport rims, bumpers, hood carbon, sport spring, and spoiler, prompting the user to make a selection. After displaying the menu, it waits for the user to input their choice using CIN and then clears the screen using system CLS. Depending on the user's choice, it calls specific functions, example, sport rim, bumper car, and others, to calculate the price of the selected exterior accessory and update the exterior price accordingly. If the user inputs an invalid choice, it calls the error message function to notify the user and sets more to true, allowing the loop to continue and prompt the user again for a valid choice. It checks if the user wants to add more accessories, add variable. If the user chooses not to add more, it sets more to false, ending the loop. It calculates the total cost of accessories by summing the interior and exterior prices and returns the total.
The provided C++ code comprises three functions for analyzing and presenting sales data. The favorite type function determines the best-selling car type by iterating through an array of car count and returning the index of the type with the highest count. Similarly, the favorite color function identifies the most popular color by iterating through an array of color count and returning the index of the color with the highest count. The sales data function utilizes this result, displaying the best-selling car type, most popular color, and the total sale amount on the console. The information is presented in a formatted manner, and the console screen is clear after user acknowledgement. Overall, this function offers a concise way to analyze and showcase key sale data metrics for a car's dealership. The provided C++ code sets up a menu-driven interface within a while loop for a car body workshop program. The loop continues as long as the variable more is true. The console displays a welcoming header with a decorative border, presenting three options, which is 1 for customer, 2 for staff, and 3 for exit. Users are prompted to input their choice, and the console screen is clear for readability. The menu structure allows users to navigate between different functionalities within the car body workshop program, with the loop ensuring continuous interaction until the user decides to exit. The program employs basic console-based input and output operation to create and organize a user-friendly interface for a workshop customer and staff. The provided C++ code initializes various arrays and strings to store information related to car types, brand, model, color, and wrapping option. The array car count is set to 0 for each car type, and color count is initialized to 0 for each of 12 available color. The program defines string array for car types, brand, model, colors, type of paint finishes, and wrapping option. The structure of an array is organized to accommodate information about different car types, each associated with specific brand, models, and paint option. Additionally, arrays for color, types of paint, finishes, and wrapping options are included. This setup provided a comprehensive data structure for managing and categorizing information within a car body workshop program. The provided C++ code segment handles the customer interaction with the car body workshop program when the choice variable is set to 1, indicating a customer selection. Within this block, the program guides the customer through the process of selecting their preferred car type. It displays a menu of available car types, prompting the user to input their choice. The program then validates the input, ensuring it falls within the exception range 1 to 4. If the input is invalid, an error message is displayed using the error message function, and the loop continues until the valid selection is made. Once a valid car type is chosen, the program updates a corresponding car type account and proceeds to the next step of customer interaction. This segment of code establishes a structure of user-friendly interface for customer to choose their preferred car type within the car body workshop program. In this code segment, a do while loop is employed to guide a customer through a selection of specific car brand after choosing a car type. The programs first increment the count for selected car type in the car count array. Subsequently, it displays a menu of available car brand associated with a chosen car type, prompting users to input their preference. The program ensures the validity of input, verifying that it falls within the acceptable range of 1 to 5. If the input is deemed invalid, an error message is displayed using the error message function, and the loop continues until a valid selection is made. Once a valid car brand is chosen, the program proceeds to the next step in the customer interaction, updating relevant variables. This coding segment establishes a systematic and iterative process for customer to navigate through car type and brand selection within the car body workshop program. C++ code segment employ a do-while loop to guide the customer through a selection of specific car model after choosing car brand and type. The program displays a menu of available car model associated with a selected car type and brand, prompting the user to input their preferred choice. The loop ensures the validity of input, verifying that it falls within the acceptance range of 1 to 5. If the input is deemed invalid, error message display using the error message function, and the loops continue until the valid selection is made. Once a valid car model is chosen, the program updates a relevant variable and proceeds to the next step in the customer interaction. In this C++ code snippet, a do-while loop is employed to guide a customer through the selection of customization options from a catalog within the car body workshop program. The program displays a menu with 3 categories, which is 1 for paint, 2 for wrap, and 3 for accessories, prompting the user to input their choice. After receiving the input, the program clears the console screen for clarity. This loop ensures that the user makes a valid selection, and the process continues until a valid response is provided. The chosen option is stored in the answer variable for later use in the program. This coding segment establishes an interactive and organized approach for customers to browse through different customization categories within the workshop's catalog, enabling them to make an informed choice for their vehicle customization.
In this segment of code, there are conditional blocks based on the value of answer. If answer equals to 1, indicating the user's choice to paint, the program sets the selection variable to paint. It then prompts the user to select a paint color and type. The prices are adjusted based on the selected type of paint, glossy, metallic, or matte. The total price is updated accordingly. Similarly, if answer equals to 2, indicating the user's choice to wrap, the program sets the selection variable to wrap. It prompts the user to select a wrap color and type. The prices are adjusted based on the selected type of wrap, standard or premium. Again, the total price is updated accordingly. This conditional block efficiently handles the user's choice and accurately calculate the total price of the selected option. In this code segment, a do-while loop is used to repeatedly prompt the user whether they want to add accessories to their purchase. The loop continues until a valid input, either Y for yes or N for no, is provided. Inside the loop, the user's input is captured and stored in the variable add. If the user chooses to add accessories by entering Y, the accessories price is updated based on the selected car type and the total price is incremented accordingly. The variable ACC is set to yes to indicate the accessories were added. If the user chooses not to add accessories by entering N, the loop exists, and ACC is set to no. In case of invalid input, the error message function is called to handle the error and guide the user to enter a valid option. Finally, the loop continues until a valid choice is made, ensuring a smooth user experience.
This code snippet is part of a larger program that likely involves user input for selecting car options, such as color, type, and accessories. It checks if the user's input for car type is 3, likely representing accessories, If so, it sets certain variables to none and updates the accessories price and total cost accordingly. If the input is not true or is otherwise invalid, it calls the error message function and sets the invalid flag to true, prompting the user to provide valid input. The code is wrapped in a do-while loop, ensuring that it continues to prompt the user until valid input is provided. The variables like selection, selected color, selected type, accessories price, total, and ACC are presumably part of the wider program's context, serving to track user selections and prices.
In the C++ code segment, the program calculates the total cost of selected customization option and update the grand total. Subsequently, it generates a detailed receipt displaying the chosen car type, brand, model, selected paint or wrap type, car color, finishing quality, and accessory, along with their respective price. The receipt also includes the total price for the customization. The console output is formatted with a clear and organized structure, enhancing readability. After displaying the receipt, the program prompts the user to press any key to continue, clears the console screen for a clean display, and prepare for further interaction with a car body workshop program. This coding segment provides customer with a comprehensive and visually appealing summary of their selected customization option and associated costs. The C++ code snippet represents a conditional block within a car body workshop program, determining the cost of action based on the user's choice. If the choice is 2, indicating staff interaction, the program prompts the staff to enter a password. Upon a successful authentication using the special password, the program calls the sales data function to display sales-related data, providing insight into the best selling type, most popular color, and total sales. In the case entered password is incorrect, an error message is displayed. The C++ code segment signifies the conclusion of the car body workshop program. It displays a closing message on the console, notifying the user that the system is closing. The multiple new line characters before the message are included to enhance the visual separation between the message and any previous output. The program then awaits user acknowledgement by prompting them to press any key to close the console window gracefully. Finally, the program returns 0, indicating successful termination. This code ensures a clear and a user-friendly conclusion to the car body workshop program, maintaining a good visual aesthetic.